Hey, what's up guys? It's your cranky classmate here, and today we're going to be doing the Unit 9 Calc BC AP review test. So basically, Unit 9 is about parametric and polar equations, and yeah, let's begin. So this FRQ section begins with a curve on the right here, represented by the equation r of theta equals theta plus cosine of 3 theta on the interval 0 less than or equal to theta less than or equal to pi, where r is measured in meters and theta is measured in radians, and where the derivative r with respect to theta is given by dr d theta equals 1 minus 3 sine 3 theta, which you could find by yourself through this. Anyways, let's start with this first question, which is find the area bounded by the curve and the x-axis. Well, if we remember the formula for finding the area of a polar function, it's really basic. It's just the integral from a to b, so like whatever the interval is, of of r squared d theta times 1/2. So yeah. So for our question, so we have 1/2 of the integral. So our interval is 0 to pi, so we just have that here. And I'm not gonna write this whole equation here, but it's just gonna be this r of theta equation squared, and then d theta. And then let's plug that into our calculator. Oh, spoilers. But yeah, r of theta equals, what was it? Oh yeah, theta plus cosine 3 theta. And then I'm just typing it out for simplicity's sake. So then we have 1/2 of the integral from 0 to pi, I believe. Yeah, 0 to pi of r of theta squared with respect to theta. Okay, so that's our answer. You could round or truncate. Actually, you know what? I'm going to truncate to pay respect to our glorious teacher. So yeah, let's go to this next question. So this question is asking us to find the angle theta that corresponds to a point on the curve with the x-coordinate of -1. Okay, so this is asking us for the x-coordinate, which is a bit trickier, but all you have to remember is that the x-coordinate for a polar graph is just x equals r cosine theta. So you just take that's how you find the x position of any distance on the polar graph. So all we gotta do is set this equal to -1, basically. So, you know what? Let's just do that. So the way we do that on the calculator is we go here, and we could do like any name for our function here, like our x function, basically. So like I'm just gonna say g of theta equals r of theta cosine theta, and then I'm gonna do y equals, what was it? X equals -1? Oh, but I'm going to do y equals -1 because this function is finding what our x point at a given point is. And then what is that? That's 1.933. Okay. So basically at theta equals 1.933, x equals -1. The x coordinate is -1. Yep. Okay, finally, part C. Find the value of theta in the interval pi over 2 less than or equal to theta less than or equal to pi that corresponds to the point on the curve in the second quadrant with the greatest distance from the origin. You know what that means? That means if we're finding the greatest of anything, it means we're going to use candidate's test. However, note that it says distance here. So it's going to be, actually, yeah, so it's just going to be the absolute distance away from the origin. So yeah, let's do that. Okay, so we have pi over 2 less, and also remember that's on the interval pi over 2 less than theta less than or equal to pi. So like we're not counting anywhere from 0 to pi over 2. Anyways, let's start with that. So basically what this question is requiring of us is we have to do a candidate's test, obviously. So let's start with finding the critical points. So we have our derivative right here. So 1 minus 3 sine 3 theta equals 0. And you know, I could like solve this equation technically, but like that's like kind of annoying. So let's just go here I'm just gonna X this out real quick because we don't really need it anymore. I'm just gonna have one. Just gonna use g of theta again. Actually, equals 1 minus 3 sine 3 of theta, and then we're just gonna do y equals 0. Oh, by the way, on Desmos you can turn off graphs by pushing this button. So yeah. Okay. Oh, sorry. Haha, sorry, brain fart. So we gotta also go past the interval x equals pi. We have to do it on the interval pi over 2, less than or equal to theta, less than or equal to pi. So just to make that easier for myself, I'm going to have these two make two lines to mark that interval. So this is where our interval is. And then the two critical points on this interval are 2.207 and... Wait. Yeah, 2.207 and 3.028. So basically, theta equals 2.207. Frick. And 3.028. Okay, and then now all we have to do is we just gotta find the endpoint values and then compare them. So this is R. Well, this is gonna be theta. This is gonna be R. So I'm just making a table for all the values we're gonna use. So our first value is pi over 2, and then R of pi over 2 is that. So 1.57. Wait, that's kind of big. Let me make that small. 1.570. And then our next value is 2.207. So that's 3.15. And then our next value was 3.028. And then that was 2.085. And yep. And then finally we have pi. What's the value of pi? 2.14. Okay, so I think we have a clear winner here. So the value of theta, where it's the greatest distance away, is 3.15. I mean, sorry, 2.207. Wait, let me find a clearer spot to write that. So theta equals 2.207. Okay, finally, use your answer in part C to find the x and y coordinate of r at point theta. So again, we just use this equation, and we also use y equals r sine theta. And then that just equals, so r cosine 2.207, or well, let's see what exactly it was since we have it here. So this was equal to 0 at 2.20767. So the x value would be negative 1.873. And then the y value would be 2.53. 2. Let me make that better handwriting. This is for you, Hannah. Yep. Oh, by the way, I forgot to mention this, but as you can see here, R is measured in meters actually, and theta is measured in radians. So we gotta add some units here. So 5.730. So this was the area, right? So it would be 5.730 meters squared. This would be theta, so it's talking about the angle, so it would be 1.933 radians, so I'm just going to say rads. And here it would also be rads, because it's talking about theta. Sorry about the handwriting. And here it would be meters for both. Yeah, just a quick note. Okay, now we'll be moving on to my associate.
Your other cranky classmate, and I'll be doing the Unit 9 Parametric FRQ and the two MCQ questions. So for for a parametric FRQ, we're given that there's an object moving along a curve and the xy plane is at position x of t, y of t at time t with dx over dt equals this, y of t equals this, and we're also given that at time t equals 0, the opposite object's position is 2, 2/1, 2, 1, and then we're asked to find the x coordinate of the object's position at t equals 3. So what we want to do here is FTC. So what we do is we set an integral from 0 to 3 of dx over dt, because that's how, and then that's square root of t plus 1 over t plus 2 dt equals x of 3, because this is the derivative for x, not both x and y. So we do x of 3 minus x of 0. And then once you plug this into the calculator, you'll get 1.114 equals x of 3 minus x minus 2, because we know that x of 0 equals 2 from this part of the equation, from this part of the problem, and then we just get 3.114 equals x of 3. So that's our first question done. So for the next part of the formula, we're asked to find when the speed of the object is at t equals 3. So to do that, we need to basically set. So to find the speed of the object, we need to. This is basic. We need to find when the. We need to find dx over dt squared plus dy over dt squared, all square rooted at that point. So in this case, we already know what dx over dt is, so that would be just dx over dt would be this part, dx over dt equals square root of t plus 1 over t plus 2, but we don't know what dy over dt is, but thankfully we have the calculator, so we don't really need to find that out. So all we have to do is essentially do set this, t plus 1 over t plus 2 squared plus d over dx cosine squared t, because that's what y is, squared at t equals 3. That's basically what we're trying to find. And then what do? You plug in this part into the calculator. So you plug that into y1, and then you're just trying to find out what y1, y3 is, and then so essentially from that you will just get speed is 0.488. Alright, for our next problem, for our next part of the FRQ, we're given that we're asked to find the distance traveled by the object from t equals 1 to t equals 3, and this is really easy. All you have to do is use your speed formula and then just make it an integral. So what do? 1, 3, a big square root, then as before, square root of t plus 1 over t plus 2 squared plus d over dx cosine squared t squared dt, and that's pretty much all you have to do. And then you just plug that into the calculator and you'll get 1.458. So then now we have a couple of FRQs. So for our first FRQ, we're asked to find the area of the region in common to the graphs of R1, equals 2 sine theta, and R2 equals square root of 3. So what you want to do is find the intersections of these graphs first. So 2 sine theta equals square root of 3, sine theta equals square root of 3 over 2, and that's at pi over 3 and 2 pi over 3. And then to find the area of a polar graph, it's 1/2 integral from a to b, which we found right here, r squared d theta. So, but for common area, what we want to do is we want to make sure there's no slivers, and we also want to use symmetry. So what we can do is, because from 0 to pi over 3, square root of 3 is smaller, then we use that first. So we go from 0 to pi over 3, and we are using symmetry to make sure we cover up every gap from pi over 3 to 2 pi over 3, and we're also making sure we cover all the first coordinate, so we get all of that right as well. And then we do 2 times 1/2 pi over, I'm gonna write this one on the next line just to make it easier to see. And we're also using symmetry for this, so plus 2 times 1/2 pi over 3 over pi 2 as our bounds, 2 sine theta squared d theta, and then once you add these together, you will get 2.799. And then for our last question, we're given, this is the parametrics question compared to the last one, which was a polar question. We're asked to find the second derivative. So to find the first derivative, you want to do derivative y over derivative x, because we're looking for dy over dx first. So that would be 3d squared over 2t plus 1, which is dy over dx. And then to find dy over the second derivative, what you want to do is you want to do dy over dx, but you want to divide it by dx one more time. So I'll show you real quick. So what we have to do here is product rule first, obviously. So 6t 2t plus 1 minus 3t squared 2t 2 over 2t minus plus 1 squared. Oh, minus 1, I'm sorry. Minus 1 squared and minus 1. Okay. And then what do we want to do? We want to simplify a little bit. So we'll get 12t squared plus 6t minus 3t squared over 6t minus 1 squared. However, we also have to remember that we also have to divide by derivative of x of t one more. So it's actually one more 2t minus 1. So it'll become 2t minus 1 cubed. And then when we do this, we this is actually a 6, my bad. So we'll get 6t squared plus 6t over 2t plus 1 cubed, because this will become 6t squared plus 6t, and then because we have squared here and one more here, it'll become 2t plus 1 cubed. Oh, my bad. These were pluses. Okay. Yeah, but that's it. Thank you, and have a good day.